Hello everyone, today we're going to look at intercepts and graphing by slope intercept. Intercepts are where the line crosses one or possibly both of the axes. The x-intercept, which is the point where the line crosses the x-axis, has the form a, 0, and the y-intercept, where the graph crosses the y-axis, has the form 0, b. So hopefully we can see by the picture, if I'm crossing the y-axis, x is 0, and if I'm crossing the x-axis, y is 0. So the other variable is 0. As long as the line has two different intercepts, like the picture we just showed, then we can graph the line using those. As long as we have 2 points, we can graph a line. The question is, though, when will a graph only have one intercept? And there are 3 different situations where that can occur. The first one is if the line is horizontal, unless it's the line y = 0. So if we have a horizontal line, it will only cross the y-axis. If the line is vertical, unless it happens to be x = 0. If I have a vertical line, it's only crossing the x-axis. The other one is if the line passes through the origin. If it goes through the origin, then its x-intercept and its y-intercept are the same, so there's only one of them. This equates to if any of a, b, or c are 0 in the general form. So if a is 0, then we've got by = c, and that's a horizontal line. If b is 0, we have ax = c, and that's a vertical line. If c = 0, then we have ax plus by = 0, and that line passes through the origin. So as long as we have all 3 of those letters in there, we have a coefficient of x, a coefficient of y that aren't 0, and we have a constant that's not 0, then our line will pass through separate x and y intercepts, and we can graph it. So that's what we're going to do here. We're going to graph the following equations by plotting their intercepts. So for our first equation, we have 4x minus 3y = 12. So it has a, b, and c. None of them are 0. And what we want to do is we want to find the intercepts. So again, remember that the x-intercept has y being 0, and the y-intercept has x being 0. So what we're going to do is we're going to replace one of our variables with 0, solve for the other, and then do it the other way around. So I'm going to find the y-intercept first. It doesn't matter which one you do first, though. So I'm letting x be 0, and I'm solving for y. So if 4 times 0 minus 3y = 12, then negative 3y = 12, divide by negative 3, and y = negative 4. And remember, this corresponds to the point 0, negative 4. X is 0, y is negative 4. And then we do it the other way around. I'm going to let y be 0. So 4x minus 3y = 12. I'm left with 4x = 12, which means x = 3. That corresponds to the x-intercept 3, 0. A lot of the time, what I have people do is they'll put these two numbers together and call a point 3, negative 4. But remember, I'm finding those 2 points by plugging in 0 for one of them. So those 2 points are not related like that. So do not put them together. They're 2 separate points. Okay, and then the next thing we have to do is plot them. So I have 0, negative 4. It's going to be right around here. And 3, 0. That's a little off. Right around there, close enough. And then we just connect them with a straight line. And make it as straight as you can. Okay. And then we're all set. So let's try another one. Y = 3x plus 6. So it's not in that general form. I could put it into it, but I really don't have to. The first thing I want to do is find the y-intercept. Notice this line is in slope intercept form, so it gives me the y-intercept right away. I know the y-intercept is 0, 6. So then I go to find the x-intercept. I plug in y = 0, and I solve for x. So I'm going to subtract 6 from both sides, and then divide both sides by 3, and I get that x is -2, which again corresponds to the point -2, 0. So again, I'm going to plot them. So we have them right here, and then I will connect them with as straight a line as I can make. Close enough. Right, hopefully you can have some sort of straight edge with you, either another pencil, a piece of paper, your calculator, or something like that. And then another one, 5x plus 4y equals 20. So again, I'm going to start by finding the y-intercept. So I set x equal to 0. And if 4y equals 20, then y equals 5. And we have the point 0, 5. Then I do the opposite. I plug in 0 for y. And if 5x equals 20, then x equals 4. And I have the point 4, 0. Okay. And then again, the next step is to graph them. And then once I have those 2 points plotted, connect it with a straight line. Oh, that's terrible. Oh, that's better. I'm not looking for perfectness, but you know, I would probably fix that. Okay. So that is how you graph using intercepts. Let's talk about graphing using slope intercept. So the first thing you got to do is make sure your line is in slope intercept form. Remember, that's y equals mx plus b. The next thing you're going to do is you're going to plot your y-intercept, 0, b. And then starting from your y-intercept, you're going to move up and down and left and right according to your slope to find a second point. Then you're going to do it a second time to find a third point. Remember that any 2 points make a line, and you want to make sure you're creating the correct line. So unless you're doing the graphing by intercepts, you really want to have at least 3 points when you're plotting your line. And then once you've done that, connect all the points with a straight line. So graph the following lines using the above method. So we have y equals 3x minus 2. So I'm going to look at that -2, my b, and plot it. And again, I'll try to make it better. All right, that's pretty good. So I've got my y-intercept, 0, -2. And then I'm going to look at my slope. So my slope is 3. What I need is to have that written as a fraction. So I'm going to choose any fraction that's equal to 3. The easiest is just putting 3 over 1. And then we're going to remember that slope is rise over run. So that means at my y-intercept, I'm going to rise 3 and run 1. So if I rise 3 from -2, I'm going to go to -1 to 0 to 1, and then I'm going to run 1 to the right. So that's going to give me the point 1, 1. I can always check that by plugging it into the equation. Is 3 times 1 minus 2 equal to 1? Yes, it is. And now I have some options. So starting from my new point, I can go up another 3 and run 1. So from 1, 1, up 3 would be 4, 1. And then running 1 would be 4, 2. So that'll give me this point right here. And hopefully we can tell those 3 points are in a straight line. Another thing I could do is I could go back to my 3 over 1 and write it as a different fraction that's still equal to 3. In particular, I could do -3 over -1. I can use that as my rise over run, going back to my original y-intercept. So if I take my 0, -2, go down 3 and to the left 1, I end up at -1, -5. Or, yes. And now I have 4 points, and again, they are in a straight line, so that tells me I did it correctly. And again, I'm going to make it as straight of a line as I can going through those points. Let's try another one. Here we have y equals 2/3 x plus 2. So again, the first thing I'm going to want to do is plot my y-intercept, 0, 2. So I have that. And then again, I'm going to look at my slope, which is 2/3, which is already a fraction. And that's going to be rise over run. So from my 0, 2, I'm going to rise another 2 and run 3. And that's going to give me the point 3, 4. Okay. And then I'm going to do it again. And just like before, I can either go up another 2 and run another 3, or I could rethink of my 2/3 as -2 over -3, and then starting back from my y-intercept, I can go down 2 and to the left 3, and I'll fix that one. Close enough. And again, we notice that my 4 points are all in a straight line, which means I did it correctly, and I'll try to make it as straight as possible. Okay. Let's try another one. Y equals -4x plus 5. So again, I'm going to start with my y-intercept, 0, 5. And then from there, I'm going to look at my slope, which is -4. And again, I want to write that as a fraction, so I'm going to put it over 1. So I'm going to rise a -4, which means I'm going to go down 4, and I'm going to run to the right 1. That's going to give me the point 1, 1. And then I can do it again. Go down another 4 over 1. Or, again, I could switch it up, and I could write my -4 over 1 instead as 4 over -1, for example. And again, any fraction that's equal to -4 works. Depending on how big your graph is, you could do something like -64 over 16, 16 over -4, right? Any fraction works. It doesn't have to be over 1. So using 4 over -1, I'm going to go back to my original y-intercept. I'm going to go up 4 and to the left 1. And then again, hopefully all those points line up into a nice straight line, which I will connect as best as I can. So again, I've been doing 4 just to show you can do it multiple ways, but I want you to do at least 3. And let's try our last one, y equals 1/2 x. So again, the first thing I want to do is plot my y-intercept. And my y-intercept in this case is the origin, right? It's 1/2 x plus 0, so b is 0. And then we're going to look at our slope, which is again already a fraction, so that's very helpful. And this is one of the reasons we don't like mixed numbers and we don't like decimals with our slopes. We want them to be a fraction. We want it to be rise over run. So using our 1/2, I'm going to rise 1 and run 2, and that's going to give me 2, 1. And then I can do it again, rise 1, run 2, or just like before, I can rewrite this negating both top and bottom, so -1 over -2. And starting back from the origin, from my y-intercept, I'll go down 1 and run to the left 2. And I can do this as many times as I want. When both my rise and run are small numbers, it's sometimes nice to make them larger. So instead of -1 over -2, what if I tried -3 over -6? That's going to give me a point further away from the origin, and that's going to help me make sure that my line is nice and straight. So if I start from my furthest point, which is my -2, 1, I'm going to do -3 over -6 from there. And then you can hopefully notice again, that's going to help me make sure that my line's straight as I go further away. I'm going to make sure that I can hit it and then go back the other way. Okay, so again, any fraction that's equivalent to your slope will work. Okay. Again, that's not the straightest line, but it does the job. So make sure that you read through the book and try out the homework, and let me know if you have any questions. Thanks.